Alright guys, so this is going to be lesson 93, equations with exponents. We are going to be working on solving equations. Remember that solving equations means we're going to be isolating the variable. We already should know that. We're going to solve an equation and we're going to isolate the variable. We're going to get the variable by itself. Now, if you are looking at the bottom right hand corner of the screen right now, you'll know what kind of operations we're going to be using in order to solve these equations. We're going to be using inverse operations. Now we're going to use inverse operations in an inverse order of operations. So we're going to take that original order of operations, PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction, and switch it over to SADMAP, subtraction, addition, division, multiplication, exponents, and parentheses. We're going to get those variables by themselves. Remember, inverse operations will always cancel. So if we see subtraction or addition, we're going to take it and we're going to flip it to the opposite with the same numbers. Division or multiplication, if we see multiplication, we use division. If we see division, we're going to use multiplication. We're just going to use whatever is the exact opposite. You've already seen all of those. The new one today is exponents. Now with exponents, you can see them in two forms, a power of 2 or a square root. Now if we see any variable raised to a power of 2, we can cancel that power of 2 out by taking the square root. Just like if we see a square root, it can be canceled out with a power of 2, because square roots and powers of 2 are inverse operations. So we're going to be seeing a couple of these things in our problems today. We're going to have to be using them in order to solve these equations. Now, make sure you have this table in your notes. Write it down. I'll be referencing it several times during the lesson today. No matter what we're doing, we're going to be following the steps using those tables in order to isolate the variable, in order to cancel out what's in the equation. So some vocab for today: quadratic equations. A quadratic equation is an equation containing a variable with an exponent of 2, but not greater than 2. So we can have the formula for the area of a square. The area of a square is area equals side squared. The side is raised to a power of 2, but there's no exponents of 3 or 4 or 5. So that would be considered a quadratic equation. There's an exponent of 2, nothing bigger. Another example would be something like x squared plus x plus 4. That would be something you might get from a binomial expansion. When we do that, we would get a quadratic equation. Now, quadratic equations are a little bit weird because they have two solutions. They have two solutions, a positive solution and a negative solution. Every square root is answering the question, what number multiplied by itself gives you the number inside of the radical? Now, we already know the positive square root. We always assume the positive square root because that's what's most natural to us. If I take the square root of a number like 9, I would think positive 3. But remember that a positive times a positive is a positive, but a negative times a negative is also a positive. So when we're working with square roots, if we have a quadratic equation, the negative answer will work too. For example, the square root of 4 could be positive 2, or it could also be negative 2. Important to note here with that is there is one time when your square root cannot be negative. It cannot be negative if we have a distance or a dimension. If we have a distance or a dimension, then we will not have a negative answer. Now, with that, we will need to introduce a new sign. It's the plus or minus symbol. A plus or minus symbol represents that something is positive, or it could very well be negative. It's written with a plus over a minus. Now we're going to need to introduce a plus or a minus whenever you see a square root sign as part of your steps to isolate the variable. So, if we're ever using a square root as our inverse operation, we're going to need to put in a plus or a minus. Now moving on, we've got our first example. Our first example says solve 2x squared plus 7 equals 25. Now, our goal is going to be to isolate x. We're going to want to get x by itself. We need to get everything that's on the same side as x out, and we're going to do that using an inverse operation in an inverse order of operations. So our first thing we're looking for is addition and subtraction. We're going to see that plus 7. We're going to subtract 7 from both sides. Not just from one side, not just from the other side, not from thin air, but from both sides. Now if we subtract 7 from the left-hand side, well, 2x squared plus 7 minus 7 is just 2x squared. If we subtract 7, it cancels out. 25 minus 7 is 18. Our next step is we need to look, is x squared by itself? It's not. We have our 2 and we have our x squared. Now, we might be confused at first. They're both 2's. Which one do you do first? Well, we can just consult our order of operations. Multiplication and division come before exponents when we're solving equations. So we look at the multiplication that we've got and we're going to divide on both sides by that number. We're not going to divide by x. We are going to divide by the number which is multiplying 2x. So 2 is the one that's multiplying, so we're going to divide by 2 on both sides. 2x squared divided by 2, that's just x squared. 18 divided by 2 is 9. Then we need to take the square root of both sides. When we take the square root of both sides, we're going to get x on the left-hand side, but we're going to need to take the square root of 9 as well. Usually you would have said that the square root of 9 is 3, but remember what we just learned about quadratic equations. They've got a plus or a minus, so it's x equals plus or minus 3. Make sure that you notice that the only reason we are including the plus or minus is because we had the square root. We did not have a word problem with a dimension or a distance, so both answers are correct. If I were to put negative 3 into the equation for x, it would work. If I would put positive 3 into the equation for x, it would work. Both of them would be squared and become 9. 2 times 9 would then be 18 plus 7 is 25. So make sure that as you're going through, you might need to check your work. You might need to make sure all of your answers work in the equation for the variable. Sometimes they might not. Sometimes they might not fit with what your equation is doing. You need to make sure that you're reading the equation carefully and making sure that your solution is a solution to the problem you're solving. If we think about our natural versus our integer numbers, our natural numbers are things we see in reality. If we have a problem talking about something we see in reality, we're going to need a natural number. So if we're talking about how many squares fit on a space, talking about things along those lines, we're going to need positive numbers. Now, example 2. Example 2 says 2x squared equals 16. Now, looking at 2x squared equals 16, we can see that x is not by itself. It has a 2 multiplying to it, and it is squaring itself. Now, we can see that we have to solve our equation for x. We can look in our chart, which is showing on the left-hand side of the screen right now, and we can go ahead and notice that we're going to need to divide by 2 on both sides. We need to divide by 2 first because the 2 is multiplication, and the multiplication comes before the exponents. Now, when we divide 2x squared by 2, we're going to get x squared. When we divide 16 by 2, we're going to get 8. I'm going to write that in just a moment. Now, x squared equals 8. The only thing we can do to isolate x is we're going to need to take the square root of both sides. We saw it in our chart. The inverse operation for a variable squared is a square root. The inverse operation for a variable squared is a square root. So we're going to need to go back to our equation. We're going to need to take the square root of the left-hand side and the square root of the right-hand side. Now, x is then going to equal plus or minus. Well, do we know the square root of 8 top of our heads? Probably not. So we're going to write the square root of 8. But we need to make sure we've got that plus or minus in front of it. If we don't, then we might forget that it needs to be there. Now 8, we're going to make a factor tree here, is 4 times 2. Now, we could stop here if we recognize that 4 is a perfect square. If we didn't, we could go further and go 2 times 2. Now, here, seeing that 4 is 2 times 2, we can see that 4 is a perfect square. The same number multiplies to make 4. So when we have the square root of 8, we're going to break it into 2 square roots. The square root of 4 times the square root of 2. Now the square root of 4 we're able to solve. The square root of 4 is 2, because 2 times 2 make 4. So we're going to replace that square root 4 below it with a 2, multiplied by a square root of 2. So our answer is plus or minus 2 root 2. Now for example 3, it's a little bit trickier. It was a problem which had a picture that went along with it. I'll be drawing it later on in the problem, right before the answer, so you can see where the problem came from. But example 3 had 2 rectangles. It had a rectangle with a length of 9 and a width of x, and a rectangle with a length of x and a width of 16. Now, they are told as similar rectangles, so we know that their side lengths are proportional. So if we put the length over the length, 9 over x, and the width over the width, x over 16, they should be equal. The one issue with that is you can't find a vertical rule between 9 and x, because one of them is a variable. You can't find a vertical rule between x and 16 either, because one of them is a variable. You can't find a horizontal rule between 9 and x, because x is still a variable, and similarly x and 16. You can't find a vertical or horizontal rule, so you need to use a cross product. Now, a cross product is when we cross multiply. We go across the equal sign. We go across the equal sign and multiply. We multiply 9 by 16. We're going across the equal sign. We multiply x by x. We're going across the equal sign. X times x is going to be x squared. 9 times 16 is going to be 144. Now, 9 times 16, if you're not sure about how that's 144, you could recognize that 9 is 3 squared and 16 is 4 squared, which means it's going to be 3 times 3 times 4 times 4, or 3 times 4 times 3 times 4, or 12 times 12. Similarly, you could also do 9 times 6 is 54, 9 times 10 is 90, and 54 plus 90 is 144. That second one is the standard multiplication algorithm. Now, we have x squared equals 144. We're going to need to take the square root of both sides, just like we did in example 2, just like it shows in our chart. The opposite operation, the inverse operation for a exponent of 2 is a square root on both sides, keeping that equation balanced. Now the square root of x squared, it's just going to cancel out the x squared, leaving us with x. Square root of 144, we're going to need a plus or minus, but it's going to be 12. We should all remember that 12 is a number which when squared gives us 144. Now I'm going to start drawing the rectangles for you so you can see why it cannot be negative 12. Now remember, I mentioned earlier the natural numbers and the integers. The natural numbers are the numbers 1, 2, 3, 4, 5, the counting numbers. The integers are the negative and positive numbers. Negative 12 is an integer, but it's not a counting number or a natural number. So we cannot use negative 12 as the dimension of a shape. We cannot use negative 12 as a length. We can't use negative 12 as an amount of objects. We can use subtracting a positive 12 in an equation, but we can't use negative 12 as our answer for the side length of one of these rectangles. So we're going to say that x is equal to 12, because dimensions cannot be negative. Now, example 4 is about a mosaic. Jamie is making a mosaic with 100 1-inch square tiles. If his mosaic is also square, how long would each side be? Now, 101-inch tiles is the area of the mosaic, because a mosaic is a beautiful piece of artwork made out of tiles laid edge to edge. So if the area of each tile is 1 square inch, and he has 100 of them, and he's making a shape by laying all those tiles down, the space covered by those tiles is going to be 100 square inches. Now, we're told that his mosaic is a square, so we can use the formula for area of a square. Area of a square equals side squared. Hey, that's a quadratic equation. Now, we can plug in that 100 for the area. We can plug in side squared for side squared because that's what we're trying to find. Now, how to get rid of that squared on the side? Well, we can look at example 3, example 2, or even to the table that we had in the beginning of our notes. We're going to take the square root of both sides. Now we're taking the square root on both sides. The square root of s squared is just s. Now the square root of 100 is 10. So we got plus or minus 10 here, but can a distance slash side be negative? Can I say that I made a mosaic with negative 10 squares on the side? No. So s is equal to 10. Just 10. Now that'll be the end of the lesson here today. Stay safe, wash your hands, do your homework, and have a nice day.